Hello everyone. Radhe Radhe and welcome back to my channel. Today we are discussing today's Codeforces contest. We're gonna discuss the first three problems of the contest. So yeah, let's begin without of and this is the first problem. Yes or yes. Um, it says that last Christmas your friend Fernando gifted you a string S only consisting of the characters Y and N representing yes and no respectively. You can repeatedly apply the following operation on S. Choose any two adjacent characters and replace them with the logical OR. Formally, in each operation, you can choose an index I such that I is in from 1 to n minus 1, and then you can remove the characters of Si and Si plus 1. That is, you can choose some adjacent characters or two adjacent characters, and then you can remove them, and then you can insert the bitwise OR of that particular expression, right? So that is what it is written here. A single Y if at least one of Si or Si plus 1 is Y. So that is what it is saying, that if either Si or Si plus 1 is true, then we'll insert a Y, otherwise we'll insert a N here, right? It says that if we perform any operation, the length of the string decreases by 1, right? Because we remove two consecutive characters and then we append another logical OR, right? So essentially the length is just getting decreased by 1. Now the problem says I'm sorry, unfortunately Fernando does not want you to combine yes or yes, as he has experienced trauma relating to a certain sound. Determine whether it is possible to reduce S to a single character by repeatedly applying the operation above without ever combining two Y's. So we want to make sure that we never combine two Y's together. That is, we can combine a Y and a N. We can combine a Y and a N. So we can add a Y in this case, or we can combine an N and a Y. We'll add a Y, or we can combine an N and a N, and we'll insert an N here. Right. These are these are the operations that are valid, right? But as soon as we encounter a Y and a Y, so we cannot perform this operation, right? So we will not be able to perform this operation, and so we need to print yes, where we can reduce the complete string into one character without ever encountering this operation. Otherwise, we will print none. So this is just a basic problem of bitwise OR. That is, if you know the truth table of bitwise OR, we can draw it as so 0 0 0 1 1 0 and 1 1, and this is result, let's say. So this is so we can see that if either of the bit is set, right? So if B is set, or if A is set, or if both of them are set, then we actually return 1 here, right? So if either of the bits are set, then we can directly set the complete bit, right? So in order to obtain one as a resultant bit, we need at least one set bit, right? So we have one set bit here. Let's say in this operation we have one set bit for P, so that will result in 1, right? So this is the truth table of OR. So don't you agree that I have a claim that if I ever encounter two Y's in the complete string, then I will never be able to reduce it to a single letter without ever encountering this operation, right? So let's say I have a string like Y and Y, right? So this is my string. So now no matter how you perform those operations, right? So let's say you first combine these two n's and now you replace them with a n. So this is something like this. then you pick these ends and then you replace again this with an end. So now this is y and y. Now you need to combine either yn or this and y. Both of them are same thing. So this will result into y and a y, right? And so you will not be able to proceed from here because this is the same as as this operation, which we were not allowed to encounter, right? So now we cannot do anything here. So this is not allowed, and you can see that in this case you will never be able to reduce this complete string into a single character, right? Because there were two y's present. So if there were two y's present and we have to take bitwise OR, they will remain, they will actually remain till the end of the operation. I'll say that. So let's say if I had something like this, now you can see that since we need to take a bitwise OR, right? So this y is never lost, because if we combine this y with n, or if we combine this n with y, this y is never lost, right? So there will exist a certain operation where these y will actually be adjacent to each other, right? So you can perform an operation over here, y and over this y and n, and we can insert a y, then the rest of the string will be same. Now similarly you can perform an operation over here. This will again be replaced by y. So this is y and triple n. Similarly you can do operation over here. So this is y n and n. Now you have encountered this thing, right? So that is what I'm saying, that if there are at least two y's in the string, that means they will never get lost, and there would come a certain operation in which they will be adjacent to each other, right? So in that case we'll print a no, otherwise we'll directly print a yes, and that's it for this problem. I'll show you guys the code. So this is the code. I'm just taking the string as an input. I'm just counting the occurrences of y. If they are actually greater than or equals to 2, I'll print a or no. Otherwise, I'll print a yes. That's it. We'll move to the second one now. So this problem says a string w consisting of lowercase Latin characters is called a suspicious if and only if all the following conditions hold. The letter s appears at least twice. So s has to appear at least twice for every occurrence of letter u. The two nearest occurrences of s are the same number of characters away from u. So if I have I'll just read this. So if I have some occurrences of u, then this is saying that the two nearest occurrences of s are the same number of characters away from u. So if s is at 2 so this was, let's say, 1 2 3 4, this was 3 distance away from u, right? So the s that will be on the right should also be 3 places away from u, right? And this has to be something like this. Then only this condition holds valid, right? Now we can also perform an operation on this string. That is, after watching you finish a string task, you find Aakarsh has gifted you a string R consisting only of letters s and u. You can perform the following operation on R. Choose an index I and set Ri to s. So we can change any u to s, essentially, that is saying. Determine the minimum number of operations needed to make R suspicious. It can be shown that under the given constant, it is always possible to transform R into a suspicious string. So first of all, if all of my characters are s, that means that we do not have any u, and so we do not need to check this condition that the nearest two occurrences of s are at equidistant from this u, right? So if all of my s or if all of my letters consist of only s, then we can just directly return a 0, right? Because we do not need to change anything, right? Now if all my if all my characters are you, what about that case? How do we handle that case? So if you will see carefully there, then these boundary elements can never be you, right? Because I have to get a occurrence of s to the left of you and to the right of you as well, right? So in order to get the same distance, they have to be present on the different sides, right? It cannot be like this, that this u is present here and then some s is present over here. If this was the boundary element, so some s is present here and some s is present here, this cannot be like this, right? It has to be present on both of the sides, right? So these boundary elements can never be u, so they will have to be s, right? Now what about rest of the u? So for this u, I'm saying that this is balanced, right? This s, the nearest occurrences of s are balanced here, right? Yeah. For this u and for this u, they are not balanced, right? For this u, the nearest left occurrence is just one distance away, and nearest right occurrence of s is 3 distance away, right? Similarly for this one also, the left one is 3 distance away and right one is one distance away, right? So now I'm saying that how do we change this string such that we change as less elements as we possibly can, because we need to minimize the number of operations. So how do we change this substring or this string such that this actually follows this pattern, that is the left and the right occurrence of s, the first occurrence of s is at equal distances, right? So if you will see something like this, that if we have something like sus, if we have an alternating string, then it is always possible, or yeah, essentially it is always possible for every u. Because if we have an alternating string and this is, let's say, an odd length, right? So this is a 5 length. So for this u, the nearest left and the nearest right occurrence of s is just one block away or one distance away, right? Similarly, if we are maintaining a how do I say, if we are maintaining an alternating substring, then I can just say that if we encounter a u here, then I just want to make sure that the left element of that u and the right element of that u is s and nothing else, right? For at least odd element or for the odd length substrings, this is always valid. If we had a sus or something like sus, us, so this is always valid for all of the u's, right? So what we can do here is that this for this u, we have one s on the left side and one s on the right side. Similarly for for this u, we have one s on the left side and one s on the right side. So this is true for all of the u's present, right? So this is essentially, we can claim that this is the minimum possible number of operations that it will take. So this is nothing but the length of the substring by 2 rounded down. Because if this was or I'll say that just a minute, I think I made a mistake. So if this was u and a u, so I'll change this to s, this to s, this to s and this to s. So this will be for 7, this will take 4 operations, so this will be length by 2 rounded down plus 1, right? For this complete substring to be or to follow this condition, right? And I'm claiming that this is only the minimum possible, this will take the minimum possible number of operations, right? Because if you do any other construction, it is simply a waste of time. You can try to construct the answer by following some other approaches, that is of you can actually try to simulate this, but I don't think I may possibly be wrong, and there could be some solution. But according to me, we can just change the alternating letters, and we can just make it like SUS US US, right? So we can follow this pattern, and then that's it. We'll just calculate the number of changed letters, right? So now let's talk about what about even length substrings. So if we had a substring like UU or UU, so we can do the same thing again for this. So SUS US, and for the last element we cannot have a U here, so we'll have an S over here, right? So this will have one extra S. We'll have two consecutive S essentially, right? And that's probably it. So we can follow a pattern. We can normally, if our string is something like this. I'm taking a random string. So if my first character itself is U, we'll have to change this to S, right? So we'll change this to S. We'll increment our operations by 1. Then we'll check if we encounter S on a current index, and if our I plus 1, or if the letter at I plus 1th index is U, then the next element has to be S, right? So if this is U, then we'll have to change this to S, right? Because I'm creating an alternating string. So in that case, I'll increment my answer by 1, and then I'll start comparing from here again. So I'm at S. If my next character is U, which it is not, so I can just keep on moving. Now I'm on S. I can just check if my next character is U. Yes, sure, it is U. So I want to make this an alternating string, right? So if my next character is U, then the next character after U has to be S, right? So I'll change this to S, and I'll move my pointer to here, right? Or here, I'm sorry. And we can keep doing this for all of the indices, and then we're good. This is the total. We can just print the number of operations at the last, right? Because I'm claiming that for every U, there has to exist a occurrence of S to the left of U and to the right of U, which are equidistant to each other, right? And I don't think there's possibly any other way to do this. If we had 2U and 2S like this, or I could take some other example, something like this. So for this U, this condition holds, right? The occurrences of S are at equidistant. But for this U, this is not equidistant, right? So for this U to satisfy this condition, we'll have to change this to S, right? There is no other option. Or if we try to make this, or else what we can do is we can change this complete thing to S. These are the only two things that we can do, right? I guess so. So I'm just saying that we can create a alternating string consisting of SU 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 S, and S could possibly appear multiple times, like SU S S S S S, and then USS USS, but U cannot appear consecutively, right? So that is all for the problem. We can just calculate the number of times I change any character, and then just print that. I'll show you guys the code. This is the code. I'm initializing our operation with 0. If my first character itself is U, I'll change this to S. I'll increment my operation by 1. Then I'll go from 0 to n minus 1. I'll check if my current character is S and the next character is U. Then I'll just check what is my if my current character is S and the next character after it is U, then I have to check what is the next character. If it is S, then we have encountered a already alternating substring, that is SUS. If it is not S, then if it is something like SUU, then we'll have to change the last U to S. In that case, we'll change this last U to S, and we'll increment the operation by 1, and then we'll increment I by 2, right? because we do not want to compare the u that was being there. That is, we were applying the operation for s and u, right? So we do not want to handle this u case, so we'll just increment that by 1. That is all for this one. We'll move to the third. So the third problem says there are n children standing in a line where the niceness of the ith child is ai. Santa is deciding which children belong on the nice list and which belong on the naughty list. An integer x is initially set to 0. Santa will perform following operation exactly n minus 1 times. So we can perform the operation n minus 1 times. Choose the first or second child in line and remove them from the line. So essentially this is saying that I could either choose the first children or the second children and remove them from the line. I could either remove this or either remove this, right? If the first child was chosen, add them to the nice list and add w to x. So x was 0 initially. We can w is, by the way, the niceness of the chosen child, right? Which is ai, nothing but ai. If we choose the second child, then we'll have to subtract w from x, right? Note that after all operations, exactly one child remains unassigned to a list, because since we are performing n minus 1 operations, one child will remain at the last when we have performed all of the operations, right? Determine the maximum possible value of x that Santa can obtain after all of the n minus 1 operations. So we need to maximize this x value, right? So I'll take a sample. So for this one, 2n minus 3. For 2n minus 3, I could, if I choose to take the first child, I could add plus to my answer. Or if I choose to take the second child, I could add a minus of minus 3 to my answer, which is plus 3. So I'll take this plus 3 and add that to my answer, and then this would be plus 3 for this one, right? Similarly, I could do for the second one also. So now we can either choose the first one, the first children, or the second children. If I choose the first children, I'll add plus 1 to my answer, and then my new list becomes something like this. Then again I can choose first or second children. So I'll maybe take the first children again. So this is plus 4, and then my new list becomes something like this. And now I can again choose either plus 3 or minus 4. Since if I choose a second child, that comes with a minus of that of the original value, right? So this is 3 or minus 4. So let's say I choose a 3 here. So I choose a 3 here, and then we have applied all of the n minus 1 operations, and the result of this is 8, which is I think the maximum possible. And yeah, it is the maximum possible indeed. So how do we solve this one? So the main intuition that this problem gives us, or that you'll have to think of, is that if you perform n minus 1 operations, any one element will remain in the array, right? So if this was my initial array, any one of the element will remain till the end. So let's suppose this was remaining till the end, because since we are performing n minus 1 operations, only n minus 1 values will get erased, right? One will remain as it is. So let's say if this value was remaining as it is till the end of the operations, so I'm saying that if this remained as it is, so all of the values that are after it, we will have to perform the second type of operations for these elements. Because if we let's say as soon as I was performing my operations, I started from here, then I eventually reached here, right? Now what I want is that I need to keep this element till the end. So whatever was coming here, we'll have to deal with it separately, and then as soon as this comes, now we'll deal with the right elements separately. And so I'm saying that all of the elements which are on the right side to this chosen element, we will have to perform the second operations, because in order to remove this element and this element, since this element will remain till the end, so we'll have to remove this one, so we'll have to perform the second operation, so minus a of I for this one, right? Because essentially we need this one to the till the end, right? So we'll have to perform the second type of operation. Now this is gone. Now we'll choose the first one that we needed till the end, and this element, right? So again we'll have to perform the second operation on this one, right? So if I perform the second operation, this will again contribute a minus ai. Suppose this was ai, right? So this will again contribute a minus ai, and then again I will remove this and I will again deal with this. This will again contribute a minus ai of whatever was the value, a minus of that. So I'm saying that if I whatever value I choose to be, or whatever value I chose, that will remain in the end. All of the values that are righter or at the right side to it, so all of the values which are righter or at the right side of this particular element, we will have to perform the second type of operation for all these elements, right? Because this will remain as it is, right? So in order to remove these elements, we'll have to perform the second type of operation, because just we'll just ignore these elements, because we have, as soon as we have encountered this, we can assume that we have already dealt with the first elements, right? These lefter elements. So in order to remove or in order to preserve this element, we'll have to perform the second type of operation for all of the right elements, right? So don't you agree that if I fix my element which will remain till the end, I could just take the suffix sum of the let's say this was I, so I could just take the suffix sum till I plus 1, and actually the minus of suffix sum, so this is minus of, let's say, a6 minus this, if this was a6, this was a5, this was a4, so my suffix sum would be minus a6, minus a5 and minus a4, right? Since we will perform the second type of operation on this one, right? And for the first type of, for the elements which are before this, now if you'll see carefully, we can prove that we can perform any of the operation on this element. So I'll just take an example. Let's say I chose this element, and these are all of the values which are on the left side. So I'm saying that only for the first element we can perform the first operation, because this is the first element itself. We cannot choose to perform the second operation. We can either choose the first person or the second person, but for the first person itself we'll have to choose the first operation, right? So this was a0. If this was a0, then we'll have to take a0 as it is, no matter what was the value. Otherwise, for all of the things, we can take the absolute values for them. So let's say a1 was 10, a0 was, let's say, 5. So I can just perform the first type of operation and then add this plus 10 to my final answer. Similarly, if this was minus 20, then what I can do is that I can perform first of all operation on this one. So I can remove this element. Then as soon as I encounter these two elements, I can first perform the second operation on this one. So I'll add a plus 20 here, because the second operation negates or adds up minus sign to the current element, and then we can remove this. Or in easy words, if I write the number of operations that are required for this, or the number of operations, or the operation that is preferred for that particular element. So let's say if this was minus 30, 40 and 50, So this will prefer the first operation, this will prefer the second operation, this will prefer the second operation, this will again prefer the first operation, and this will again prefer the first operation. So I'll give you guys the intuition that if we encounter a element which wants the first operation, because this was positive, right? So this wants to take the first operation so that this can maximize the result, right? So in order to take this, or in order to perform the first operation, that is take this first element, we'll have to take all of these elements into account first of all, right? So you can assume that we would have already dealt with all these before elements, right? And now I can perform the first operation on this one. Now we have dealt with all of these elements, and now we can separately deal with this. Now similarly, if I want to perform the first type of operation on A1, I can assume that I have dealt with all of the previous elements, and now I can perform the first operation. And if there was a element which wanted the second type of operation, so these negative elements want the second type of operation. So for these cases, what I can do is, these elements want the second type of operation. So once I have cleared all of the elements which are left to it, right? I have dealt with all of the elements which are left to it. Now this is the first element, A1. This is the second element, this is the third element. So if they prefer to have the second, to get the second operation, if these elements prefer the second operation, then I don't want to remove this before removing them, right? If they want to take the second operation, then I will keep this element as it is, and then I'll first remove this element, right? This will act as my first element, this will act as my second element. So we can then successfully perform the second operation, right? And then we can add a plus 20 here. Similarly, this has now been removed, and this is the first element, and this is the second element right now. So now we can again perform the second type of operation over A3. So now I can add a plus 30 here, and now we can remove this one also. And now I'm left with the first element. So now I'll add the first element, the plus 10, and now this thing is gone, and now we'll again continue from here. Let's say if there was a minus 100 here, so this meant that this needed a second type of operation, right? So this needed the first type of operation. I'll just perform a first type of operation, move over here, right? So I'll add a plus 40 here. So now the adjacent or the next element needs the second type of operation. We have already dealt with all the elements before this. Now the A5 is the first element, right? So if my A5 is the first element, I will not remove this element right now. I will remove all of the elements which require the second operation. So I'll take this and this. This is the first element now. This is the second element. I'll choose this, and I'll perform the second type of operation on this A6, and I'll add a plus 100 over here, right? And then I'll continue. As soon as I exhaust my count of 2, then I can perform a first type of operation over here, and then I can add a 50. So essentially what I'm doing, I could just take the absolute values of all of the AI, right? So no matter if it was a minus 100 or plus 100, we can just add the absolute value of that. So we can create two prefix sum, one for two sum, or two one prefix sum and one suffix sum actually. So we can create a prefix sum of all of the absolute values and suffix sum of all the negative values. So if I choose to perform an operation over on this one, then I'll have to perform the negative operation on these elements. So I'll get the answer by suffix of I plus 1, and then I can get my the answer for the left one from prefix of I minus 1. And we need to perform the first type of operation on A0, right? So we cannot take this A0 and take the absolute value of this. If this was minus 5, then we would have to perform the first type of operation on the first element, right? So we'll add a plus 0, plus A0, whatever was there in the first element, right? So this is the answer for this particular if I choose this particular element to remain at the end of the at the end of all of the operations, right? So we can similarly do this for all of the elements. Let's say if I choose this to remain at the end, let's say if I choose this to remain at the end, so now we can take negative sum of all these elements and absolute sum of all these elements, right? So this is essentially it. This is I'll show you guys the code. So I'm creating two prefix sums, or one prefix sum, one suffix sum. I'm doing a prefix of 0 equals to 0 because I do not want to take a0 into account, right? And this is just creating prefix and suffix sum respectively. Now if my I is greater than 0, then I can just take the I minus 1 of element of the prefix sum of n minus I minus 1 elements, or prefix sum of absolute value of I minus 1 elements, and then I could if my I is less than n minus 1, so I can take the negative prefix sum or negative suffix sum of the rightmost elements, right? So I can take the negative sum of these elements. That is what I'm doing here, and I can add a0 to my answer if my I is not equal to 0, right? If my I is 0 itself, then I want this 0th element to remain till the end, so I will not take this a0 in that case, otherwise we'll take a0 always, and then we can maintain a maximum and we'll just print this maximum. That's it. This is it for the problem. So I hope you got the problems. I hope you enjoyed the solutions. I genuinely hope that you got the solutions. I'm doing this after a while, so pardon me if I made any mistakes or if the solution was unclear. I'm trying to become better at teaching, I guess, so please give me a little time to adjust to this thing. Again, I'm trying my best. I'm trying to give my best over here. So yeah, with that said, I'll see you guys in the next one. Maybe we can tomorrow try to continue the road to expert series, or try the lead code problem of the day. But anyways, yeah, I'll see you guys in the next one. Thank you. Radhe Radhe.